Hello everyone. In this assignment support video, we will look at the main steps involved in the creation of the numerical model for your assignment and also some aspects of the result analysis. So we start with the RS2 software open and we go to analysis, project settings, where we define our important project settings. So initially we make sure that our units are in kilopascal, kPa. We go to soil profile, and since we will be using a soil profile input as borehole data, we need to check this box. And next we need to define our stages of the excavation. Now you would have noted that the excavation will be done in 6 stages. So we define 7 in total, including our initial state. So we create 7 stages, name our initial state like so, and create stages for each excavation. So we name our stages as excavation 1, excavation 2, and so on. And define our stages. The other options for this purpose for your assignment could be left as the default values. So once you say OK, you will note that the tabs at the bottom of the window indicate the stages of your excavation, the initial state and the 6 excavation stages. Now, as you selected soil profile in the previous window, you would see that there are extents of the soil profile. So looking at the assignment task sheet, you will note that we will have to define our extent for our model as follows. To 150, 120 to 60. So this would be the extents of our numerical model. The next task is to define our material properties. So to do this, we go to properties, define materials. Now in the assignment task sheet, you would know that there are 4 main formations called Melbourne formation, MF1 to MF4, and we will be using 2 boreholes on either side of the excavation to define our soil profile. So we start by defining, we can rename our materials. We can call this MF4, starting from the top going down. We can delete this. F3. And as given in your assignment task sheet, you can define the values. So Poisson's ratio for MF4 would be 0.3, and the Young's modulus in kPa would be 300,000. Strength parameters we will be using an elastic analysis for this purpose, and our tensile strength will be 0. We have 30. And we have 37. You'll need to fill up all the data in the required fields by referring to the assignment task sheet. Once you have input all your data, you can also make sure that you have field stress and body force selected in this field for all your rock types. So once we have defined our materials, we can now look at creating our soil profile using borehole data. So to do this, we go to Profile, Borehole Editor, and here we can define our boreholes. So since we will be using 2 boreholes on either side of the excavation, we'll define our boreholes. We can give the location for our boreholes. So the distance approximately 70 meters, elevation is 120 meters. The name is BH215205, and here we define the layers by their thickness. So the approximate thicknesses for each layer, we can define them. Insert layers below. Once we have defined, we can add our other borehole and give the location, which is approximately 110 meters along the x-axis. We can name this as BH405 and define thicknesses as in the previous case. When we hit OK, we see our soil profile defined within the extents of our boundary. Our next task is to define the external boundary of our simulation. And to do this, we go on to our Geometry tab and select this icon, which is Add External Boundary. We select the external boundary as a window. So we start from this point and drag our cursor to this point to select our window. Once we have defined our external boundary and our soil layers, we can now import our excavation boundary, which is provided to you as a DXF file. So to do this, we go to File, Import DXF, and select the tunnel excavation boundary file that has been provided. So we want to import this drawing as an excavation boundary. So we select excavation and confirm. So you will see that we have several points in very close proximity in this imported figure. So you would like to simplify these boundaries so that it helps in our subsequent meshing process. So to do this, we go to Boundaries, Simplify Boundary, select our excavation, confirm by right clicking, and confirm. So this will reduce the number of points and will help in our meshing process. So next we can define our excavation stages by using stage boundaries using this icon here. So as you can see, we can define boundaries that will indicate which stage our excavation is in. And before we do that, we can use lines as construction lines to help us guide in this process. These lines are temporary and can be removed after you draw your excavation stages. Once we have our construction lines, we can set about drawing our stages of the excavation. So for this purpose, I'm using a simplified boundary. You can also make it a bit more complex. Once you finish drawing, you can remove the construction lines that assisted us. And now we have our excavation along with the internal excavation stage boundaries. Now we can define what happens during each stage in our excavation. So initially we have all the soil layers intact. During excavation 1, we will remove the top heading. So we do this by right clicking, assign material and select excavate. We need to make sure that this section is also excavated. And we click on stage 2, excavate this component. Select stage 3 to remove this part. Stage 4, which removes the top 2 headings. Stage 5, which removes the left hand side bench. And finally stage 6, the right hand side bench. So now you can see that during each stage, different parts will be excavated in the order that you have given. Next, we will also assign a discontinuity. We will be considering just one discontinuity for this purpose. We select it as a joint, and we can apply it approximately as given in the figure in your assignment task sheet to be like this. So next we look at applying the loads in our simulation. So to do this, we go to loading and we select this icon. Now we are told that there is a load of 25 kilonewton per square meter applied on the top surface. So we apply like that. And next we want to mesh our domain. So we go to mesh, go to mesh setup. We start by discretizing our boundary and then we apply our meshing. So once meshing has been completed, you also need to pay attention to the restraints. So we go to restraints from this top icon and we make sure that our restraints are appropriate. Now in this file, the restraints have already been defined, but if it has not been defined, you can use these icons to define the restraints as required. So on either side, we have a restriction of the movement in the X direction, and at the bottom we have a restriction for movement in the Y direction, and the top surface is a free boundary. We also have pin supports at these edges, so you can define your restraints using these icons. Once you have defined your load, your restraints, and also meshed your domain, you can compute your numerical model. Once computing has been completed, you can look at the results using this interpret icon. So you would start by looking at what is known as the strength factor. The strength factor is the ratio between the rock strength to the induced strength at a given point, induced stress at a given point. Now this means that if the ratio is less than 1, there is a potential likelihood of that point failing. So initially we have the situation looks good, and as we move with the excavation, we see that around the excavation the strength factor drops to values below 1. As we proceed, we see that even the surface is adversely affected by this. We can also look at the displacement. In terms of total displacement, we can check the displacement vectors. or we can even select our vertical displacement. We can plot the vertical displacement on the surface to see the surface subsidence resulting from the excavation. Now, as part of the assignment, you are asked to decide on and to implement an appropriate support methodology. So to do this, you can create a new file and define a support system. You can do this by going to support and add a rock bolt pattern. So you can define how long you want the rock bolt to be, the rock bolt spacing, and then define your rock bolts like given. Bolting can be done for different stages. You can also go to supports at the top, add liner, and add a liner for a given surface. You'll have to select these segments to do that. Once this is done, you can change your properties of your rock bolts, the type of rock bolt and the properties, and also your liner materials. So you can change your bolt and liner properties. You can change the orientation, and you can even define different types of bolts and different types of bolt patterns to improve on the situation that you saw previously. So the assignment task is for you to design an appropriate support methodology and to re-evaluate the model to see the changes that may occur to the strength factor, displacement, and any other relevant factors. So this concludes the assignment support video, and if you have any further questions relating to your assignment, we can discuss them in the practice class. Thank you.